Hi, my name's Andrea. I'm coming to you from QPedia Thermal e-magazine. QPedia is the media sponsor for this year's Cooling Zone Summit in August. I'm with Dr. Kaveh Azar. I was hoping to ask Dr. Azar a few questions about the thermal management community in general and its upcoming short course on August 27th.
Hi, Andrea. Glad to be here and talking with you.
Thank you. Dr. Azar, you've been in a number of conferences, countless chairs, keynote speakers, and have always played an active role in the thermal management community. Why do you think education is so important in this field?
Andrea, this is a very good and insightful question. Thermal management, obviously, as we all know, is a critical juncture point for the successful launch of any kind of electronics product. Now, why education is so important at this juncture is very, very simple. Either we are new to the field or have come from school. When I say new to the field, we could have been a seasoned engineer. We come to an electronics company with a mechanical engineering background or electrical engineering background, and we're given the responsibility to do the thermal management of electronic systems. The unfortunate part of it is we are not really exposed to the specific field of electronics cooling. Not that there's a new heat transfer and fluid mechanics or thermodynamics in there. We've all been exposed to the fundamentals in the undergraduate, graduate courses. But when we get to electronics cooling, there are some very, very unique parameters that makes the problem very difficult. And these stem from awkward geometry, multiple materials, multiplicity of heat sources on the board, and as a result of it, some of the traditional stuff that we've seen in our electronics, in our thermal management classes in school or been exposed to may not necessarily and readily apply. Therefore, those of us who've gone through this education by School of Hard Knocks, being exposed into the process, have an obligation to come back and educate the people who are coming to the field new, whether from a school or a seasoned engineer picking up new responsibilities. But we have to find and extend and share our experiences and exposures that we've had in electronics cooling to the people who are going to get involved. And those are the little nuggets that makes the problem much easier to solve than just going through a formal heat transfer or fluid mechanics or thermodynamics class. So the problem is very difficult to solve. Education is very important, and especially education with experience is very important to share and hopefully help the people who are coming on to solve this problem more readily.
Thank you very much. On August 27th, you'll be giving the short course Thermal Measurement and Experimental Design in Electronics Cooling System. Could you please give a short overview on what you'll be presenting?
Oh, absolutely. Let me just grab this board to explain further. I don't know whether you can see this board or not. Just an example, I pulled a board from our dead board bin at ATS. And just to give you an example of what we are confronting and how we're trying to solve the problem, and why a course like this is of value to our participants, or any thermal or mechanical engineer who's going to do electronics cooling. You look at this board, you see, if I hold it maybe a little bit this way, you see multiplicity of geometries, you see multiplicity of power sources, you see different packaging, you see plastic molded packages, you see metal packages, you see the way heat sinks attached in a pair of clips, you see connectors, strand geometry, and so forth. And as a thermal engineer, I have the responsibility to come back and see whether this device is going to be functional in the application that the board is going to reside. This board could be sitting vertical, could be sitting horizontal, could be sitting face down, depending upon what the configuration is. Now, we have all these very powerful computational analytical tools, but at the end of the day, we have to verify our solution. So you've run your CFD simulation, you've done your analytical modeling. Now you want to know whether this is correct or not. So for me to be able to calculate the temperature of this device, I need to know what the air velocity and temperature is, or possibly what the pressure drop across this board is. So in this course, we're going to look at both at the component, board, and the system level, how to measure the thermal parameters. These include temperature, velocity, pressure, heat flux, and also learn about flow visualization. That's very, very important.
Thank you. Why do you think thermal measurement is so important?
Well, at the end of the day, again, that's a very good question, Andrea. At the end of the day, we have to verify. There is nothing like measurement, as it is dangerous to produce data, but the reality is people believe data versus simulation and modeling. And when we do in situ measurement, oftentimes it's very, very difficult to do the in situ simulation. And we don't have an exact answer as to what's happening. Imagine, for instance, this board, if assume for the sake of discussion, this is the telecommunication board, and we have multiples of these sitting in the environment. Or, for the sake of even discussion, single board, if it is facing down like this, or facing up like this in a natural convection, or even in a mild force convection. These are tough, very difficult problems, especially with the complex geometry that we see. So I need to verify my simulation. I've got these powerful tools that I've purchased, and now I've gotten answers. I want to send my product out, and I need to know whether the answers are correct or not. Because if I don't have a correct answer, I could jump into a whole different cooling capacity. If I could cool this with a simple fan and a heat sink, if my simulation is wrong, if I didn't put the right boundary conditions, if I didn't verify my answer, where the measurement is going to come into the picture to help, it's going to cause me to go and consider a higher capacity cooling system. And a higher capacity cooling system is going to cost me more. It's a very competitive market. We want to make sure that every aspect of our solution is minimized as far as cost is concerned, so we can get our products out to the market and be very, very cost effective with it. And reliable, obviously.
Thank you. Could you tell us a little bit about the live demo you plan on giving?
Yes, Andrea. But what we have is, as some of you may know, we have developed a whole host of thermal test instruments at ATS. And we use these on our regular work on the characterization or consulting work that we do for a variety of clients. And I've always believed that it is of immense value to see an experiment in progress. I can stand in front of you and talk about hot wire anemometry, laser Doppler velocimetry, I can talk about heat flux gauges and so forth. But when you see that in operation, you have a totally different appreciation and some of the challenges that you have to face in order to collect good data. Remember in the previous question I mentioned people believe data and they don't believe analysis. And so the data that you generate has to be as accurate as physically possible. The live demo is going to show you the challenges and the issues that we have to confront when we want to do a clean measurement. And you can see how these equipment are used. Some of us who've never done these before, it's very difficult for us to imagine, for instance, what a hot wire anemometer is, how it works, and what the challenges are. Granted, it's a sensor, but there are errors associated with that. And when we see them put in an experiment, you can see where the errors are and how to eliminate it when you do a measurement. So the demo is going to encompass all of those and give you a very good sense of what the measurements are all about.
Thank you very much. What do you hope attendees take away from your short course?
My greatest hope is, first of all, they get a good understanding of what measurement is all about. Secondly, get a good understanding of measurement is not a game. It's a very detailed process. For me to be a good experimentalist, I have to be a very good analyst. And I hope to convey this very strongly to the folks who participate. And then last but not least is understand the tools available for measurement. So when you go back to your offices and you have to conduct a measurement or you see a data being collected, you have a chance of judging what to look for, what are the pertinent parameters to look for. So you select the right instrument, you place it in the right location, and when you look at the data, you question the validity of the data, despite the fact you may have put it together yourself, as you question the results of an analysis and simulation. So if those three items are accomplished, which in the past we've done it, hopefully we can do it again. I think it's going to be a very successful course for our participants and obviously very gratifying for us who are given the course.
I agree. Dr. Azar, thank you very much for your time. We look forward to seeing you at the coolingZONE Summit, August 27th through 30th in Cambridge, Massachusetts. Thank you.
Thank you, Andrea, for giving me the opportunity to speak with you and the audience.